Hey everyone, and thanks for listening to another episode of DIB Innovators. Today I've got a great guest, Brook Leonard, CEO at Rogue Space Systems Corp. Brook, thanks for connecting today.
Dave, great to be on the show. Thanks for having me.
Oh, this is super fun. Brook, or as I call him, Tank, goes back to our Air Force days, so teaching at weapons school, so it's fun. But let's go a little bit of background just for listeners. Tell me about your Air Force time and then how you transitioned to become CEO at Rogue.
Absolutely. 31 years in the Air Force, got a chance to do a lot of different things. Dave, as you mentioned, spent a lot of time at our United States Air Force Weapons School, both as a student, instructor, and a commander, doing a lot of test and training, bringing new platforms on board and understanding how we integrate air power into other domains. I guess my space journey started off there, learning how to teach GPS guided munitions, how to learn all about the GPS signal. Gave a couple space weapons officers some backseat rides and kind of took it from there. I came back as the commander and ran basically our multi-domain integration bowl where we had non-kinetic effects and we integrated space fires for the very first time. Of course, it was super classified back in 2006 and 7 when we were doing that. We got a really good understanding at the tactical level about space. Deployed a bunch of times, as we all did during that era, both to Iraq and Afghanistan, commanded at several different levels in Korea, training wing out at Luke Air Force Base, and then also in theater. And then at the strategic level, I worked with the Secretary of the Air Force as first senior military assist for Secretary James and got to see kind of how the sausage was made. At that time, there was a lot of pressure from Congress to up our space game. And so we did a lot of those things, kind of precursors to what we eventually did was split out a new service, but got to see that and how we were tackling launch and making sure that we had resiliency and access to space. And so got to see that from the strategic level. And then after a couple more tours in Iraq and Afghanistan, came back as the chief of staff for U.S. Space Command. And at the operational level, got to be involved in the stand-up of a combatant command. You don't do that every day, but to be able to kind of follow the path as we broke cyber command and space out of strategic command where we had them and build our new geographically owned combatant command. And so we got our own AOR 100 kilometers and up and got to stand that up from 43 people to get it on the trajectory to where it is today, around 14 to 1,500 folks. And then after that, right before I retired, helped the Space Force and Space Command understand how we would do command and control and make sure that we had good components within U.S. Space Command, which is really important across all the different services, but then also how the Space Force presented forces to the other combatant commands and how we integrate all that. So got to work with an organization that basically was the precursor to Space Force's space, which is the space component of Space Command. And so I saw a lot from the air and space domain, from testing to operational to combat. And, as I retired, was really excited to stay in the fight and keep working on, really tough problems with really great teams. And so that journey kind of led me to where I am now.
That's very cool. So you have to be, from standing this, time of weapons school, and we're first figuring that out to now, this last endeavor over in Iran, just the combined effects across our joint force to include space and cybers. Big picture thoughts on how that's come full circle.
Yeah, I would say it's come full circle and then looped back on itself several times. We mentioned the time. So 2006 and 7, we were integrating space effects. We had code words to overcome security level. But this was a boots on the ground approach. I can't really go into the scenario because of the classification, but we use real-time space effects to do things, that were very human, very tactical, as well as operational and strategic. And so it was really surprising to me when I came back to Space Command and we were bringing together the different services and multi-domain operations and how much we had not thought about it. And I think mostly that came out of just the repetitiveness of counterterrorism operations, fighting ISIS and the Taliban, which, they don't have a really large space force. And so we had I think in some ways gotten into a rut of space effects just being countercoms and not, from the perspective of what would it be like to fight with an enemy that had their own space capability and would use their space capability to target the joint force, and how do we need to combat that? And then on top of that, how do we do integrated effects across a much larger scale exercise than, maybe, a particular SEAL team, taking down a target. And, those were very precise, very limited effects. Like, how do we think about broader effects and the timing and tempo of space operations with cyber operations, with air, land, and sea operations? And so we've kind of had fits and starts over the years, but very happy to see kind of how things have been integrated and also how we have really come together as a joint team, particularly in the operations that have gone on so far in Iran.
Yeah, pretty amazing for sure. Well, that's good. Well, let's pivot over to Rogue. Now, your current role as CEO. Give us a background on Rogue's mission and what you're doing right now.
Yeah, so Rogue is basically building the infrastructure to increase maneuver for mission and markets. That's the way we kind of think about it. And then a lot of people are like, maneuver, yeah, that's a military term, but from a commercial or civil perspective, it's the agility to adjust to what the opportunities are out there and to take advantage of them, vis-a-vis, competitors from a campaigning perspective, if you're talking military, or competitors, in a business market kind of perspective. And so iteration is really how we get to innovation, and you need reps and sets to be able to do that. And so whether you're growing your market, be a new market, or your market share from an older or more established market, or you're trying to campaign against the enemy, you need to have that iteration. And right now, what we do is we spend a whole lot of money and a whole lot of time building a specific bespoke satellite for a particular payload and launching that into space, and it dies, and then it becomes debris. And so that's really an unsustainable, it's also a pretty slow method to be able to increase our technology and our capability, both economically and military. And so what Rogue is doing is essentially building the infrastructure to be able to get those reps and sets in a little bit cheaper and definitely a lot faster. And so we're building satellites that are chassis and integrate very rapidly with the payload. And so now you're loading and not integrating. And then we also have the capability to just launch payloads into space via what we call a space shipping container. And that allows you to move things around in space without having to build satellites to do it. We have a workforce of satellites that are very maneuverable and can dock and move those containers around. And then we're building a persistent platform that's unmanned and intelligence with incredible capabilities on it to be able to host those payloads. And it's a modular erector set. So you can create an aircraft carrier if you want. You could create a multi-sensor platform. You could create a manufacturing depot or a fueling depot, kind of sky's the limit. But that infrastructure is going to allow folks to get their payloads to space faster, to be able to integrate the new technologies while they're on orbit rather than waiting for relaunch. And so we think it's going to be a real powerful piece to how we're going to progress and how we, quite frankly, need to progress, vis-a-vis the competitors that are out there.
That's great. And so to take it maybe down a level for those that aren't super, comfortable with space, are you vertically, so you've got your rocket,
Right.
go back to, Rector set, Knuckle Dragon fighter pilot talk. You got your rocket.
Yeah.
Then you've got your bus, satellite bus, right? Which is where you have the arms that come out with, it can be lots of different things, but that's the actual thing that's orbiting. And then you've got payloads on it, right? Which is the different technology capabilities, sensors, different things that would be integrated into that. When you covered what you talked about, what are you building specifically at Rogue?
Right. Specifically, so we're not building rockets. We're letting Elon Musk and Jeff Bezos and several very highly capable companies do that. And quite frankly, them driving down the cost to launch is a super, important piece of this. But what we're doing is basically disassociating the cab of a truck with the container that it pulls around. So, beforehand, what we would do is if we wanted a payload, so like let's say you wanted to get your Earth observation payload to space, you would integrate that with a very specific satellite bus. And so integration means a lot of engineers, a lot of money, a lot of time. And so instead of having that be a complete set that just goes down the road and eventually runs out of gas and is just debris, we're separating the cab of the truck from the payload. And so we're building a satellite chassis that can literally just be hooked up to the payloads that it's taking into space. And so now you're moving your mission capability and it's not integrated into the vehicle that you're using to do that. And so what that allows you to do is just move that payload around. You can replace it on orbit. You can integrate it real quickly before launch. And you can then have a series or, different amounts of payloads integrated on a single platform. And now you have a multi-mission infrastructure out there, carrier, if you want to call it that, depot, if you want to call it that as well. And so it's changing the paradigm of how we go to space. Instead of bespoke, fully integrated, we're now getting into exactly like we do it in other domains. You've seen shipping containers on trucks, trains, you name it. And everything's focused on getting the payload as cheaply as you can and as quickly as you can to wherever you need it. But you need an infrastructure of ports and docks and ships that can be quickly loaded on. And so we're building out that infrastructure. We have the shipping container built. We kind of have your tugboats or your ships built. And then now we're building sort of the ports of LA, if you will, in space, unmanned persistent platforms to be able to have the infrastructure to do that.
So you're putting your shipping container, if you will, onto a rocket and it's going. And so it's effectively, it is the bus, but you're vertically integrating the thing that goes there, and then it gets released into orbit, and that's a base, and now you can connect or pull things out of it, do whatever you want. It's basically just, a shipping container with different capabilities that can be put in or pushed out.
Yeah, and the neat part about that is you don't have to, it doesn't need to have the full gamut of propulsion, satellite, or solar panels, flight computers. It doesn't need to be that exquisite. It's literally, I wouldn't say it's as simple as just a metal container, but you don't have to pay for extra mass, extra engineering, extra accoutrements. It's literally just the payload and a quick connect to where you can either quick connect it on the ground to a satellite and then, basically take the chassis that you have and make it into, like a Ford F-150 or a bread van or whatever. You take chassis and you add different things on it. And so our modular design allows you to take a satellite bus chassis and make it into a mission capable entity really quickly. But then also, because of that modularity, you can, after you've launched that capability, if you wanted to swap out a new sensor, you could take the shipping container that has that sensor off the satellite, replace it with another one. And then on top of that, you could also combine all these different shipping containers on an island or depot like I talked about. And then you'd have much broader capability across a single platform that's supplying power, compute, and other things that your payload might need.
I mean, part of a standard bus, right, is like having, the solar arrays, the
Right.
And
Yeah.
so how are you getting the power? Is it each individual payload has itself, each payload is self-contained, or
Yeah, it gets the power from the host. So, like, for example, if you took the shipping container and you mated it with our persistent platform, the persistent platform would deliver the power, the communications, the edge compute. And so that container in and of itself doesn't do that. It needs to be mated just like a tractor trailer, right? Needs the tractor to kind of haul it around, or you could take that shipping container and put it onto a train.
well, you are putting out one, I would say, complete satellite bus with all the capabilities, and now you're connecting different storage containers with capabilities inside of each one together to create, that's kind of the power, the home docking station, if you will.
Yeah, exactly.
So you created that as well and got that into orbit, so that's part of the main one, or are you using other, satellites to connect to?
Right. So we're building the chassis. If people want to use that, it comes with a bunch of different quick connects, and so you can assemble payloads very rapidly into kind of whatever sort of mission kit or mission capability you wanted. But we're also providing, if someone wants to build their own satellite and just integrate a spot for a shipping container, if you will, then they could put a specific payload in that, and then we could dock with it and change out that payload if they wanted to upgrade that in space. So it's kind of how you want to use it. You can either use the modularity on your own satellites, or we're building chassis, that are custom fit to this modularity, and then we're also building a larger platform. And who knows how the ISS, what's going to happen with it, but it's really important. I think, we're seeing a lot of push forward and folks that want to manufacture in microgravity. And so that's another use. We're seeing a push starting to build in terms of refueling. And so how do you, store fuel and get that around? And so having space in space to be able to do the things that we want to do. And we feel like unmanned is the right way to go. We feel like autonomous, intelligent operations with lots of edge compute is also another key feature of really speeding up the economy in space. And so that's what we're building into our platforms. And then you can connect your payload through these shipping containers, very modular, and kind of create whatever you want.
Thanks for breaking that down to that level. I think that'll be helpful.
Yeah.
I know you really don't probably talk about your capability as shipping containers, but like that was good for us. You don't have propulsion or anything, so how do they dock? Is it the main host station that's going to then do the rendezvous?
It is. Yep. Yeah, we use our main chassis and we put on basically a logistics mission kit onto that chassis. And it'll eventually have the capability to dock directly with the shipping containers. It will also have a robotic arm that will help move those shipping containers around and basically take off old ones and replace them with new ones. And so that's kind of our workforce that does move the shipping containers around in space between our persistent platform and another satellite. Or if we wanted to deorbit after manufacturing, it would rejoin with the deorbit vehicle and transfer the shipping container to it.
Okay, awesome. What do you have in space right now? What's actually operational?
So we've launched 2 satellites so far, currently operational. We have what we call our orbital task platform 2. And so it has edge compute capabilities. It's got some cameras and different sensors on it and a couple hosted payloads. And so we're trying to help other folks out, get them into space and innovate as rapidly as possible. And so that's one of our business models is going out there and asking for folks that need a ride to space. And we offer full services in terms of we'll take care of the regulatory licensing piece, we'll take care of launch, and we'll take care of mission operations, test, and get the test data back to them. And so the current platform we have in space has 2 different customers on it that we're testing out their capabilities. And then very quickly here in October, we're going to launch our next test platform that will have an upgraded edge compute capability as well as some other customers. One of the things that we're running kind of near and dear to the world you and I used to live in, we're running a government sponsored situational awareness payload that's similar to TCAS. And so what it's able to do is kind of take the space catalog. It also takes, where the planets and stars are, and it takes light observations from different sensors and it coalesces them into collision avoidance algorithm to where it will eventually be able to automatically move your satellite to avoid any known debris or other satellites trying to rendezvous on you, or even ones that are unknown that it detects and synthesizes that data. And so similar to how airlines avoid, using IFF, you'll be able to have this onboard your craft and do collision avoidance. And then from a military perspective, do intercept avoidance or intercept calculations with it. So pretty powerful software that we'll be running on the next satellite that we're launching.
So what do you think, as you now have been on both sides of the aisle, both in the military and in space, dealing with space as well as now the commercial side, what's the biggest misconception, you think military leaders or have about space as the warfighting domain?
Misconception wise, I think that there's, not everyone's like this, but I would say a very generalized misconception is that you could isolate those effects. I mean, we're seeing a little bit of, hey, you close the Strait of Hormuz, like gas prices are going to go up. I think that's a no brainer with everybody. Back in the States, we're like, okay, yeah, a couple more dollars here or there into the gas tank. No big deal. If we had, a fight going on in space and you had the equivalent of closing the Strait of Hormuz in space, you would have incredible wide-ranging effects that would affect you and I and everybody else a lot deeper than a couple cents at the gas pump. And so I think there's still a very, sort of, hey, space is out there, you know, not a big deal. We could probably overcome, effects in space and, especially against a near peer type adversary that had counter space capabilities themselves. Just how critical and important that domain is and how much it touches everybody's life across the globe, every second of the day. And so I think we're slowly waking up to that, but I still think that that's a big misconception that we're not planning and organizing for as much as we should.
Yeah, speaking of that as contested environment, I mean, I feel like, multiple guests on here that talk about this, that we're not doing very well. Thinking of that, we're making some baby steps, orbital maneuvers, refueling, but the capability of space. Let's use Iran for example. In theory, you could have a satellite with 500 drones that could be deployed anywhere in the world in like 50 minutes. You know, that's significant. You could have weapons. How do you see? Just as a general, are we moving quick enough in this area, or do you have concerns? And piles a little bit on your previous answer, but
Right. Well, and I got to see it, like you mentioned, from both sides of the table at Space Command, looking at, wow, where are these gaps between capabilities and vulnerabilities? And then on the commercial side, I get to see the other end where, there's a lot of ideas out there and how quickly are those ideas being brought into the military arsenal or into our capabilities just, in general. And I would tell you, I don't think we're going fast enough. Obviously, I think the Department of War, Secretary Hegseth, and this administration agrees with me on that one, or I'm agreeing with them that we need to go speed at scale. But yeah, space, like there's just a couple things that are just crazy to think about. So, we fly over and the enemy flies over our country every day, right? And so, you and I would never be able to just, trundle over, Chinese airspace, right? That would be a no-no. But we do it every day and the Chinese do it to us. The other part about it is, we had a couple airliners, that would fly over the Nellis test and training range. But every day you have military satellites interacting with commercial and civil satellites, from all nations and brands. And so that's a crazy thing to think about, in space as well. And then just the incredible reliance that we have on that domain. And so there's just some super significant factors that I don't think have come to roost and where we've said, there's some incredible opportunities here, but there's also some incredible dangers and vulnerabilities. And so I think wrapping our head around that is starting to happen and we're starting to accelerate. But there's a bunch of people on the same track who have figured this out. Namely, China, I think, is our biggest threat in that area. And they're running pretty fast. And what they're doing is they're taking best in breed and incorporating it into military exercises. And it's like my dad, old retired Army guy, used to say, it's not a capability until it's rehearsed. Well, one of the powerful things that I think China's been doing is taking their technology and getting it into operational units rapidly and then iterating rapidly off of what they see, what they learn in exercises. And I think we could, kind of tear a page out of that playbook and help ourselves out a little bit there.
yeah, absolutely. It is slightly terrifying when you start talking to folks that are just engaging, like, holy cow, there is definite vulnerabilities and huge operations. Do you think, talk to me about, your perspective on capital markets in space? I know it's changed significantly, the ability to get venture funding and, are you guys funded that way? And how do you think that can help accelerate, or is it hindering our ability to, get things into space and capability growth quickly?
I would just say alignment and integration, I think, could be helped out. There's a ton, like So we're funded by a great family office. We are looking to get into some venture capitalists in a round that we're just starting. So just money in general, I think, is out there. And the understanding that we need to invest in and we need to accelerate innovation, I think, is out there. The DoD wants to innovate and accelerate. Absolutely. But I think it's trying to align all those different efforts. We look at what is the military doing in terms of research and development, and then what signals are they putting out to investor type communities and businesses that are saying, hey, these are opportunities, these are contracts that are coming, this is funding that we're going to make available. And then also on the commercial side, what's dual use, what's good for the military and good for commercial. I mean, that's the golden egg. If you can get both of those, that'd be awesome. But aligning all of those different, what is commercial doing? How can the military leverage that? What does the military want to do? Is that backed up by how they're doing research and development? Is that backed up by the signals they're sending on contracts? And are investors, VCs, and businesses picking up on those signals? And so I don't see as much alignment as I'd like to see, because with the amount of money flying around and also the amount of money that's, the opportunity to make money that's there, I feel like we could really do a lot better if we aligned all those things. And so some sort of, if we looked at it from a national perspective, so what is our national space policy and how are we getting after that? This administration's put out some good focus on space superiority and how we get after that. And OSD R&E is moving out on that plan and on that direction. We're seeing military budgets align to a lot of that. I'd like to see a more holistic plan that's put out there that everybody can sink their teeth into, backed up by the signals that both the government are putting out, aligned to then where business and technology is headed.
Very good. Yeah, I agree with that. If we look, let's pivot back to then rogue space. So one of the things you talk about is, AI at the edge. What does that mean in space? I mean, why can't we just do it
Yeah.
to the ground, zip information back and forth? I mean, with the intercoms and that's really quick. So what is the advantage there? What are we trying to achieve, and where's that market going?
Right. Yeah, a couple things there. So I think first of all, kind of a characteristic of the space domain is we don't know all the time and we can't communicate all the time and at the speed that we would want to. I mean, you and I flying around, like, if a wingman said, hey, I'm targeted, that meant that come hell or high water, they were either going to kill the thing or they were going to tell you if it maneuvered, until it became a non-factor. I was the chief of staff in Space Command, and we had a target of interest, and they briefed it out that said, we were able to reacquire it every single time it came back around. And I'm like, okay, so you weren't tracking it. You were observing it every time it came over a particular station, and you got lucky that it hadn't moved when you weren't watching it, right? And so our concept of tracking and that continuous awareness of what things are doing is a lot different. And also timing, you get out into cislunar, obviously, huge push to see what happens on the moon, but just the speed of light going out that distance, there's a delay in what's happening. And so because of your awareness not being complete and always up to date, and then your communications being delayed, you're going to have a capability to react without a human in the loop. Now, you might have a human on the loop, but there's going to be times and situations where you're going to need to react faster than you can understand and command and control. And so that has to reside locally on the satellite, or closer to, where the action is. So that's one aspect of it. And then the other aspect of it is it's expensive and it takes time to transfer all the data. I mean, we're collecting, just mega amounts of data with all the different sensors, but that's just data. That's not intelligence, knowledge, or decision quality information. And so if you could actually take and calculate that on the edge, on the satellite, where the sensor is, and then only send the data that's important, again, you're going to have better quality information. You're also going to have it faster, and that's going to help out decision making. And so for those reasons, being able to calculate on the edge or to be able to run some sort of autonomy, which requires edge computing and calculations, you're going to need to have those capabilities. And so, to me, I think that's one of the most important things as we continue to grow on the commercial and military side that needs to grow with us is our ability to compute on the edge and to execute autonomous operations.
Yeah, well, I do think centers in space will be interesting. Very different banking model.
Yeah, there's some problems there, you have to solve, like everybody talks about, well, space is really cold, right? And I'm like, yeah, it's also really hot. And there's a lot of radiation out there and it's hard to cool things in a vacuum. And then you still have to connect that compute to the users that want that commute. So you have to have obviously the comm connections back and forth and technology is developing all of that out. And so whether it's a better place to compute in space versus on the ground, I think there's going to be advantages and disadvantages, but you will need compute in space, period. And so whether you're replacing, giant Earth, bound data centers with data centers in space, I'm not sure how that's going to go, but at a minimum, you're going to be able to have a lot of compute in space to do the things we want to do up there. And so at a minimum, you're going to have some.
Who's your biggest customer now? Are you working with the DOW or are you working more with commercial partners to give their capability to DOW?
Right now, the Department of Defense is our biggest customer through research and development grants. They funded a lot of our technology development, which has been great. And, we're turning those back into capabilities for the military. And so probably 70% of our revenue is tied up in that, 30% on the commercial side. And with the commercial side, we're just trying to get people into space faster so they can develop their technology. And so as a host platform, as a logistics company, our pitch is we'll get you to space 5 times faster, 5 times cheaper. And then we're developing the infrastructure, as I described earlier, to help you sustain your mission in space, longer and better. And so right now on the commercial side, our revenue is derived from hardware and software hostings and running test profiles and getting the information back to our customers.
Okay. So where do you see you guys in like 5 years? Where is Rogue going?
Well, what we hope to do is demonstrate rendezvous and docking. And right now, there's a few, if any, companies that have demonstrated that from an autonomous sort of man on the platform. We dock every day, not every day, but we dock with ISS. But in terms of autonomy, satellite to satellite docking, we're looking to demonstrate that in 2027. And alongside of that comes, refueling capability if you want to be able to do that through the docking portal. But to be able to connect and unconnect multiple times is going to be important for our logistics model. We're also building out our edge compute capability. We have an LLM, as I mentioned, on our edge compute platform right now. And so we're exploring, can it help us actually operate the satellite in a more efficient and effective means? And then what does it look like to give, command authority to that language model on the edge? And so we're exploring that piece. And so kind of the technology to make our platforms intelligent at the same time as the technology and the demonstrations to do the docking is really important. And then we're going to come out with our space shipping container, if you will, kind of like if it fits, it ships. So we're going to, basically offer that to the commercial and military community. And if they want to integrate their payload into that, and then when they're ready to ship it, they just send it to us. And then we get the license and regulatory side done. And we have a scheduled flight to space. And so very rapidly, someone could take a payload and send it to us in the shipping container. We mount it, shake it, bake it, and launch it. And so starting to offer that FedEx kind of speed, if you will, at getting to space, we're looking to demo that at the end of 26. And so those are the big pieces, intelligence and autonomy on the edge, the ability to do rendezvous and docking, and then the ability to do rapid integration. Those are our big, kind of pushes here in the next year and a half.
Nice. Is it easier I think this probably changes monthly, but talk to me about trying to get on a scheduled for a rocket.
Yeah.
to get that. Is that getting better?
It's getting better. There's more providers. The reliability is going up. And so, yeah, that's definitely getting easier. And so you can schedule kind of, where you want to go, when you want to go, who's going there. Obviously, the size of your payload matters as well. So that part is really not an issue. The part that we're trying to improve it in kind of the same way SpaceX, you know, made it like a standardized production line, reusability, taking all of those tenets. We're trying to apply that on the how do you get the payload and the bus together, right? And then up in space, how do you sustain it rather than just launch it, let it burn in, or let it be a piece of debris. And so on either side of the innovation that SpaceX has done, we're trying to do similar innovation. And then now, you have a payload, you're a customer, you want to get into space to develop your technology or, to enter into a new market. Obviously launch is no problem, like I said, but integration still is. And so if we can smooth out that and make that faster, and then you launch your payload into space, you operate it, and now you need to refuel the craft to extend its life, or you need to change out a component, again, increasing your return on investment with those capabilities in space, you're going to be able to do that. And so we're trying to build the infrastructure on either side of launch. But yeah, launch is pretty much a non-issue.
Awesome. Well, good. Well, I've got kind of lightning round, if you will, there at the end, just to ask you some questions. Probably not a lot of commentary, just get your take. So let's go. What's your biggest myth or misconception about selling to the Department of War?
I think the biggest myth out there is they don't want to innovate. I think they do, but they have the responsibility of integrating that capability that's on call 24/7.
Very good. Hardest lessons you've learned so far as you've become CEO of a defense company?
I think it's speed and patience have to coexist in, all of your operations. I'm a go fast, get there right now, but you do need to think about the fact that, is this a viable market? Everything you do costs money, and money drives, your entire operations. And so I would say balancing both speed and patience.
Perfect. Number one piece of advice you would give to someone who wants to start a defense tech company?
This easy one. Besides having a lawyer on staff, I would say focus. You feel like you're going to starve to death, but you're actually going to drown. I think failure comes from trying to pursue so many different things.
I love it. I have a sacred cow in defense tech that you think will be proven false.
I think the idea that people want to go and live in space. I don't know if that's true. I grew up in the era of Aquaman and living underwater and things like that. I think humans love living on God's green earth. And so I think this idea that we're going to have, colonies in space, maybe colonies on other planets, but I think sort of living in space and human involvement, I think it's going to go much towards autonomy and machines doing those operations.
And where do you think the biggest growth opportunity is in defense right now?
I think it's in infrastructure. So right now we've concentrated so much on payloads and products, but we don't have the rail lines, the towns, we think westward expansion, right? And the telegraph and the rail lines and the towns that kind of fueled the settlers and the gold rushes. And so the infrastructure behind that, I think, is the biggest opportunity right now.
Awesome. Well, thanks, Tank. This has been awesome. That's all the time we've got. But if people want to follow up, see what you're doing or get involved with you, maybe take something to space for them, how's the best way to do that?
Yeah, if they just want to jump on our website, rogue.space, and they can see all of our offerings, get in touch with us. And again, we'd like to get you to your mission or market and enable you to operate there and dominate that market. And so that's what we're all about. So thanks.
Awesome. Well, it's been great. Super fun. Learned a lot. Broke it down to a level that I was able to follow. So appreciate that.
That's great.
But let's keep in touch, and thanks a lot.
Yeah, take care, man. See ya.